Good evening, guys. Am I audible? Guys, am I audible?
Yes, audible.
Okay. Why is my sound is getting echoed? Is
For
it the
me, it's
same with
normal.
you? Now I think it's fine. Yes.
Okay.
Yeah. Just 1 minute. Let the people join. Hardly 10 participants are there. Let people join within 2 to 3 minutes. We will start. Fine.
Just noted, sir.
Hello.
Yeah. Hi, Muzammil. Want to say something?
Hello, yes, sir.
Yes, you are audible. Please say. Sorry, I'm not healthy right today, so I have weird sweaters and these caps. It's only due to the ill health. But I didn't want to skip this class. That's the reason I prepared myself well such that yeah, the weather should not hurt or it must not come within us. Yes, want to say anything, Muzammil?
Yes, sir. Assalamu alaikum. Audio-
Yes, Muzammil, say would you like to say anything?
Yes, sir. Yes, my audio element.
Yes, yes, you are quite well audible to me and others. Please say.
Sir, this is my new uh, Zoom. Last time, not my audio not coming. My audio not going. Mm,
Okay, but now
so,
it is very good. It is quite smooth and clearly audible, Muzammil.
okay, sir. This is new install Zoom application and put my email and new application.
No worries. Okay, right. Just on our previous class, does anybody remember what we have covered? If I open the Jamboard, I think my screen must not be visible yet. Let me share my screen. Visible now? Right now?
Yes, sir. Yes, sir.
Yes. Fine. Hmm. So does anybody remember what we have done in the last class?
Decision tree we talk.
Decision tree. Very good. At least there are few who remember and they are in coherence with what is going on. Thank you. So, decision tree. So, what have you understood by this name decision tree, my dear?
There is option yes and no.
Okay. It is what is you are able to recall that there is an option of yes and no. What else? Everybody should participate, please, because without knowing what we have done in the yester class, it is not a good practice to move ahead, and that's too when mathematical implementations are concerned. Yes or no?
Yes.
Yes. So,
Last time.
ha- so had we seen literally a tree
Root
somewhere?
node. Root node.
Yeah, let me write it. Root node, it's called here. Root node, not a rot node. Root node. Like you have a tree, we have root. From the roots, a trunk goes up, and then a leaf start. So we call it root node. Root node. Then after root node, we have splitted the node. Split has happened.
Leaf node.
That yes, that split was on the basis of yes or no. Fine. Those who have
Yes.
an answer given yes or no. So that split is based upon yes or no. After the root node has been done, and the split happens at every branch. If you remember, we call the level at which the splitting is done. We call it a branch. It's similarly like starting from the first node, we have split something. Say here we had six yes of a scenario and say five no's. So we will split amongst here, say three yes and three no's. So what is remained? Three yes and two no's. Similarly, it will go again, getting splitted, again a split, again a split, again a split. So this Thus, the node which doesn't split further, mind it, let me change the color. The node which doesn't split further is called as, does anybody remember? The node which doesn't split further is called as,
Leaf node.
yes, very good. You have seen the recording. Good. It's called leaf node. No further split. So, what is the intuition you have drawn after you have seen such a architecture? That what is actually happening? Like you have seen the game of Akinator, no? Last time, Akinator, that genie who was responsible for guessing the character we are thinking about. Is it a Saruk Khan or a Ritik Roshan or a some female celebrity or a cat or a dog or a mobile phone or tablet, anything you wish for? That genie was able to guess it for you, and that was using a decision tree. Yes or no? So we had used the website called Akinator. Does all of you well versed with that? Is there any doubt in the whatever we have done last time? This is the whole structure. And may I ask that yes, what was the, what may I call it, parameter to qualitatively and quantitatively, or what may I call quantitative and qualitative ta- parameters to know the purity of the decision tree. That okay, if I ask, do you remember the keyword which we have used and we have mathematically computed? Do you remember that keyword, the word entropy? Somebody given the answer entropy. So this entropy is either having a three values. One is 1, another is 0, and the third is any value between 0 and 1. Yes or no? Point 0.5, point 0.7, point 0.3, point 0.2. But wherever it is having a 1 value and a 0 value, okay, out of the given things, root node, split node, a leaf node, and a branch, out of this value, where does the entropy is 1? Sorry, where does the entropy is 0? Any idea? Okay, what does the entropy reflects? If I change the slide, what does the entropy reflects?
There is no further division.
Okay, if there is no further division, what is the value of entropy, my dear?
0.
0. Means when in a decision tree is no further division, at which node? Say it loud. Root node. Can you imagine that at a root node, if there is no further division, would there be any decision tree form?
Leaf node.
Leaf node. Correct. Why leaf node? Because there is no further node after a pure leaf node. Yes or no? Say here.
Yes,
See,
yes, yes.
after this, there is no further division for such a node. So such a nodes are called leaf node. No further split, and when there is no further split, entropy goes 0. Is this understood?
Yes, sir.
Yes. But what happens if entropy goes 1? Unity. What does it mean if entropy is a unity? If I draw the graph for you, it is a probability versus entropy, which is denoted by H of S. And here it goes. The value of Hs becomes 1, where the probability is 0.5. Now, when does the entropy goes 1? See here, entropy is 1. At what type of probability the entropy is 1? Please try to find the insights from this graph. What would be the scenario with the probabilities such that their entropy goes 1, unity, maximum? What is the values of yes and no? Nobody remembers? Have you seen that if you have 50% distribution, 50% yes and 50% no's, what is the entropy value? Say you have 3 yes and 3 no's. Suppose, what is the value of entropy here?
1/2.
1 by 2. Oh my god, only 1 by 2. Just calculate. See how the entropy is calculated. H of S is 3 by 6, log of 3 by 6 to the base 2, keeping minus sign here. Again, minus of, again 3 by 6, log of 3 by 6 to the base 2. Am I going correct? It becomes 1 by 2, log of 1 by 2. 1 by 2 is written as 2 raised to the power minus 1, minus sign, minus of 1 by 2, log of 2 raised to the power minus 1. What does it comes to be? Minus into minus goes plus, where this minus sign comes in the coefficient of log. So minus minus plus, so it becomes plus half. Log 2 to the base 2 becomes 1. Okay, log 2 to the base 2, this value becomes unity. It is a property of a logarithmic, that logarithmic of a number to the same base becomes 1. So half plus half. So half plus half becomes unity. It is not 1 by 2, whosoever answered this. Are you understood?
Hmm.
So whenever there is a equal probability that there are equal things to be splitted in a either side, either yes or no. It could be 3 yes, it could be 6 yes, it could be 78 yes, but similar no's must be there. So whenever there is a 50-50 possibility of a probability to happen or to occur a class, then we call the entropy goes unity. And between that, whether it's a between that, we call the entropy lies between 0 and 1. See here, between 0 and 1, between 0 and 1, between 0 and 1. So everywhere other than 50-50% and extrema, other than at extrema and 50%, it is between 0 to 1. But what it was measuring, that the model is actually calculating the entropy and making it 0, it means that now there is no further subdivision and a decision tree has reached to its final prediction. Means whether it's a cat or a dog, whether it's a bottle or a pen, whether it's a human or non-human, whether there is a traffic light or no traffic light. Okay, so likewise such things are being calculated by the what is called machine using mathematical operation, and one of the mathematical quantitative expression was entropy. Fine, this is we have covered. Now is the time that we see it quite in detail. Now if you remember, we have talked about information gain. Has anybody remember information gain? This information gain says that suppose you have say suppose feature 1, feature 2, feature 3. Suppose there are three features, although there would be more than 7 to 8 features in a given data set. So suppose there are three features, and out of this feature you want that your machine learning algorithm must pick the best feature best feature and split accordingly. Are you getting what I'm saying? You want your machine to pick the best feature and split based upon the feature predictions, means based upon the feature analysis, whether the feature is having as many nodes or as many yes or no's. So, how to select amongst the feature, that which feature to select for splitting in a decision tree? Are you getting what I'm trying to say?
Yes, sir.
Okay. Like suppose you want to purchase your house, or you just want to classify whether to purchase your house at a given locality or no. There would be more than 10, 12, 14 features. Out of that, if say there is one feature that is called locality. Locality matters a lot. Then we call the what else we can say, the area of the house. This is also one of the feature. Then we can
Price.
say uh,
Price.
price
Nearest
could,
place.
no, price is the final thing, buddy. Price
Hmm.
is the final thing. Yeah, price could be the thing. Okay, now I can take a price as a input here. Why? You are right, because we have to predict whether to purchase or not. Okay, fine. So price would be one of the feature. So suppose a person who is an investor who has to just invest the money, he or she would only think about the price along with the locality. Are you getting? Means a good locality and a good, means optimal price or a cheaper price makes him a rich in a coming future. But if you are living, means if you are purchasing it for your own sake, for the living purpose, for residential purpose, you will definitely seek along with these two the area also, that in what big area you are getting that, along with the other features. So the gist is, yes, the gist is that based upon these, out of these three, which one to select first? Are you getting me? Which one to select first initially? So this decision for a machine is to be taken by a parameter which is called information gain. Are you getting why we are studying information gain here?
Yes, sir.
Information gain, which is given by the entropy of the root node. This is called the entropy of root node. Root node means root node of every feature. Root node of every feature minus, we call it the S of V, the upon S. We call it the, what is called fraction of the feature which is being selected at random, say suppose, and h of sv multiplied by the, what is called entropy of the selected feature. This is the formula given in the literature. Formula given in the literature. We will see how to solve such things. So remember this h of s of root node. First you have to calculate the root node, the entropy of the root node in the, by the similar thing which we have done, what is called in the yester class. And now we are only required to add this ratio multiplied with their concerned entropy. Let's check how to do it. Now suppose you are having feature 1 with another split C1 C2, and feature 1 is having say 9 yes versus 5 no's, and you again have a different feature, say the locality, it is having different concerns, different classification, and they further has their own distributions. So based upon these two features, how should I know, or how should a machine know that whether to select feature 1 or to select feature 2 to start my decision tree, or such that my decision tree, if a decision tree starts well, it ends well. Because in a machine learning, if a garbage is in, garbage is out. But if you pre-process your data, then you are refraining the garbage to come in. So say the feature 1 is having 9 yes and 5 no's. If a 9 yes and 5 no is there, then may I calculate the gain, overall gain of, say, my whole data set S for feature 1. Mind it, for feature 1. That is given by that particular thing only. So if I calculate h of s, here we had h of s for a root node minus of, you remember, sv by s multiplied by h of sv. H of sv. Let me rub this. Now h of s is given by, how should I calculate h of s? Can anybody answer me? If you know that feature 1 is having 9 years, guys, answer me.
9 by 18 why, sir?
9 18.
9 by 15. 14.
Yes, 9 by 14. Please add it. It's simply an addition. 9 over 9 plus 5. 9 plus 5 is 14. 9 by 14 minus of log of. See, you have to take the same log. No worries. 9 by 14 minus of. This is for yes. Now goes for no. 5 by 14 log of same. 5 by 14 to the base 2. Please give me the log value of this. Do you know how to take log? Will anybody calculate this value for me? Is anyone interested? Okay, please do it. Say, even if I calculate my calculator, if I have a scientific calculator, let me check. View scientific. Oh, so I have 9 by 14. If I write here 9 by 14 into multiplied by, kahan gaya? Where is multiplication here? Okay, multiplied by, are you able to see log here? Ln, here it is ln, not a log. Here log of 9 by 14, say log of 9 by 14, it is coming this multiplied by, okay, now you have to add. No, minus sign has come. So we have to multiply it by minus 1. Minus 1. What is that? Is it the same answer coming? No. Something is there. Okay, no worries. Actually, it is done better on the scientific calculator if I have. Let me check. Do I have a scientific calculator here? Okay. So if I go for this value, I cannot even. Okay. Suppose I have a written value here. This is 9 by 14 to the base 2 here, mind it. You have to keep the base of the log 2 such that then only such answer comes. Say if I go for logarithmic calculator, logarithmic calculation,
Yes, sir. Before was right answer 0.23.
0.23.
Minus before value came, it's right.
Okay. No, that is fine. But I just want to say that yes, say if you do not apply proper what is called parenthesis, then answer won't be acceptable, or answer might go haywire, that it might deviate.
Mhm.
So this is the only concern. That's why I am seeking an online calculator,
Okay.
online logarithmic calculator. See here we have online logarithmic calculator. So it is log of what was 9 by 14?
9 by
Yes,
4.
9 by 14. So it is log of 9 divided by 14 and bracket close. Where to close the bracket? Let me close it. Enter. This is value multiplied by 9 by 14. If you multiply the answer by 9 by 14, if I open the bracket, I'll write 9 divided by 14. I think answer was correct then also,
Mm.
minus 0.233. Now I have to reduce this value. Do remember this 1233, okay, minus 0.1233, minus of, I have to do 5 by 14,
Yeah.
5 by 14, sorry, 5 by 14 multiplied by logarithmic of, sorry, I have to go log of 5 by 14. Have I written it correct?
Yes.
Yes, sir.
Yes. So this is coming off minus, no, just we have to recheck. Let me, how do we, just remember minus 0.1233. If I go that way, I have to go to this step. Yes. Now if I simply remove it, 5 by, okay, 5 by 14, log 5 by 14, control C and control A, sorry, where to clear it, C, okay, control V, no, it is not taking, no worries. 5 by 14 answer into log of, sorry, 5 by 14. Now you have to multiply it with minus 1, 0.159699, and plus, because
Minus
minus, yes, point, what was the answer? 123345
0.1223.
means a similar, yeah, sorry, anybody said anything? So say the value is around 0.28304. So hereby actually that value went for log to the base 10. See here, mind it, it is not saying that this is taking a log to the base 2. Like say suppose if I, okay, let me write this answer as 0.28 here. 0.28 for the time being. See, this is how you go for real time answers, real time work. Say if I go for log of 10, suppose. Does log 10 to the base to 1? Does log 10 to the base to 1? Yes or no?
No.
Yes, sir.
No.
No. It is only log 2 to the base 2 is 1. So it means what is the base here? The base is 10. Yes or no? So
Yes.
the thing is, if you take log 2, suppose, and you do not give a base 2, it must not come 1. And here is the answer. So the answer is variable because here you are not taking a logarithmic of anything, any number to the base 2. You are taking, sorry, it is taking base 10, not base 2. So to make anything to the base 2, let me again check how it is taking log, no, log of, if I make it say 2 close, and no, I cannot, no, there is not a possibility to convert it to log. Okay, here we have log to the base 2, suppose, and if I go here to calculate, see, log 2 to the base 2 is 1. Now it is fine.
Yeah.
See here.
Raise 2 to
So
the power 1 equals to 2.
yes, so anything, suppose if you are stuck somewhere, just open this calculator, log calculator, write a value. What is the value? 9 by 14. So your value is, say, suppose I write 9 by 14 and calculate. Log 9 by 14 to the base 2 is, please provide a x value. So if I go for this, again it is saying, please provide a numerical value. What is the 9 by 14? Give me a quick answer. 9
Point
by
six four two
14,
eight.
0.64287143. 0.6428, 0.6428, fine.
5714.
Yes, yes, no worries. Now see, log 2, log this to the base 2 is actually giving you a value of minus 0.63755. Okay. Now you just, when you multiply it with, mind it, when you multiply it with this value, control C, when you multiply it with uh, control V, see, you are getting a value of 0.409, around 0.41. Fine. So here the value of 0.41 is received. Similarly, again a value of 0.45, 0.46 shall be received, 0.43 shall be received, because we have a 5 by 14 and log of number. Say suppose if you go for log 5 by 14, so 0.40 and 5 by 14, 0.3571. Remember, 0.3571. So if I go for 0.3571 and calculate, it is giving me 1.4855. So 1.4855 multiplied by, so sorry, if I copy this, control C, multiplied by control V here. So it is coming 0.53. So 0.53 and 0.41, does it makes to 0.94?
0.53.
Yes,
And
yes.
0.41. The previous value came 0.41. So this value 0.28 is not a correct answer. If it is calculated for log of number to the base 10, then this would have been a correct answer. Even I have written, my answer is also same. The answer is 0.94. It is approximately 0.94. So the value of gain for feature 1 is 0.94. And suppose okay, now this is this a value of gain? Is this a value of gain? What we have calculated here, is it entropy or is it gain?
Gain.
No, see here, guys. Gain is given as h of s minus of sv by s into h of sv. So we have just calculated h of s. See here, h of s. Last time, p plus log p plus p minus log p minus. This is just an entropy here.
Which of us?
But we have to,
Professor, yes.
yes, we have to subtract this value to the this particular ratio which is yet to be calculated. So do go for it. That's why I'm taking it at a very small speed such that you understand, you digest it. What is h of sv? What is h of sv? Sorry. For say feature 1 and c1, say suppose you had a feature 1 of 9 Ys, 5 no's, and it was getting split into 6 Ys and 2 no's. And how many Ys are remaining?
3
3
Ys,
Ys and 3
3
no's.
no's.
Yes. So here you call it a C1, you call it a C2, means class 1, class 2 in a given feature. Then for a class 1, you again calculate a local entropy. This would be called as local entropy for class 1 inside a feature 1. So this will be given as minus again 6 by how much? How to calculate an entropy? It entropy is calculated within add the node. So
8.
add the node, we have 6 by 8, very good. 6 by 8 log of 6 by 8 to the base 2 minus how much? How many nodes are there?
6. 3 by 6.
6 of 3 by
No,
6.
no.
No.
For C1, guys, for C1. See here, at C1, what is the scenario?
6 by 8.
6 by 8.
Again 6 by
See,
8.
for no. See it mindfully. You have already done it for yes. 6 yes by total number of split. So now how many are remaining?
2 by 8.
2 by 8.
2 by
Yes,
8, yes.
2 by 8. Now got it?
Log 2, 2 by 8 again.
Yes, thank you. So now this comes out to be 0.81. Please calculate it at your end also. This comes out to be 0.81. So again you will go for h of sv. Now give me a very quick answer. H of sv for C2. What is h of sv for C2? See here, 50% probability. What is the value of h at 50% probability?
3 by
6 by
6.
3.
Arey,
6 by
see
3.
here. What is the value of h at 50% probability?
3 by 6.
See here, 50%
4.5.
probability. Value of h.
Ah.
0.5.
Yeah, it's
0.5.
1. It's unity. Whenever you see 50% distribution, simply close your eyes and give your answer unity. Fun. That's it.
Yes. 3 by 3, yeah.
Okay.
Yes. So it becomes one. Actually, it saves your time. It reduces time. So sooner this is done, now you are well ready to calculate the gain now. So to calculate the gain, if I use a different color, say gain, if I calculate the gain in front of you, gain is given as h of s of the root node, which was calculated as 0.94 minus what is the value? What is the ratio we had? S of v. S of v by s. S of v by s means you had column 1 here. 6 plus 2, how much?
8.
8. So 8
8.
upon 8 by what are the total yes,
9.
sorry, here, sorry. What are the total number of yes and no's for
14.
9
feature 1?
divided by 5.
14.
1 4.
Okay.
So 8 by 14. Mind it. Now we are going class versus feature. Previously we were only confined to within a, sorry, at a node. Now we are traveling from a node, from a parent node to the child node, or from a child node to the parent node. Are you seeing? the flow. Previously, if you see, mind it, sir, 6 by 2. Here it's 6 by 8 because 6 plus 2 is 8. Here, 2 by 8 because 2 plus 6 is 8. But now here, 8 by 14. So here,
Total.
nowhere the total is 14. But the total is 14 is lies in the root node. So 8 by 14 means the number of what is called total probabilities of the class divided by total probability of the root node, that is the parent, multiplied by the this entropy of the class 1, which was calculated as 0.81, plus what is the next thing? Next thing is 6 by 14 again. Why 6 by 14? Because you have to check for its C2 also. So 3 plus 3, 6 here. 3 plus 3, 6. 6 divided by total number of probabilities in a root node. Now what should I multiply it with? What should I multiply it with?
0.81.
0.81 is already been multiplied for C1, sir.
1.
C,
HS.
6.
yes. See it carefully. This belongs to the root node, which is done, already calculated. Now this belongs to, actually this is a summation part. So this is the probability SV. This is called SV, which we have written. Probability we are standing at class. This is called S. This is the probability, or sorry, the outcomes, which were total outcomes of the feature node, and this is the total outcome of the child node, multiplied by the what is this, local entropy of the child node, plus again what's called outcomes, total outcomes of the child node, that is this 3 plus 3, divided by total outcomes of the feature node, that is the parent node, that is 9 plus 5, multiplied by the local probability of the class C2. What is the local entropy of the class C2? See here, we have calculated.
This is 1.
That is 1.
1.
Thank you.
Yes.
Now, when you multiply such things, it is not a calculation, hectic calculation of what is called log. Nothing log is available here now. So this comes out to be, sir, around equal to 0.049, or may I call it equal to 0.5. May I call it 0.5?
Yes.
Yes, it is.
So no, I cannot call it 0.5. I must call it
Why, sir?
0.005. See,
0.05.
see here,
Oh, yes.
0.049. So 9 will make 4 as a 5. Mind it.
Yes, yes,
4
yes.
as a 5.
Yeah, around up to 5.
Yeah, yeah. But I cannot skip the significant digit. So suppose now you found a good idea about that. Yes, somebody is asking anything. So you found that a gain of a given data set for feature 1 is found out to be 0.05. Now suppose you had another feature, feature 2 and feature 3. So for say gain of the whole data set for feature 2 is found out to be 0.054, and gain of for given data set for a feature 3 is found out to be 0.048. Now out of these three, which gain is the highest value? Out of these three, sir, which has the highest value?
0.048.
Highest value. Highest value.
0.05.
0.5.
0.57.
Feature 2.
Yes. Here it is. It is as
Feature 2.
simple as that. As simple.
Yes.
I have not changed the any significant digit. Mind it, I have not kept as 1.5, another 0.05. I have kept everything after the second significant digit. This is C. second significant, second significant, second significant. So G of F2 is highest out of that, G of F2. So how the machine would decide, it will take the feature 2 to split and to create a decision tree out of all the given features to it. Am I understood what is being done by machine?
Yes.
Say suppose feature 1 was the locality, feature 2 was the price of the house, and feature 3 was the area of the house. So if the gain of price is greater than all other rest of the features, then decision tree will start from the root node having the things called price. And then the further splitting starts. Understood what I'm doing? So that how to decide that which feature to start with the decision tree. Because previously
Yes.
we were only doing that what is decision tree, what are the key components in a decision tree, and what is the matrix due to which we decide that okay, when a leaf node becomes actually found as a leaf node by the machine, because machine has no understanding of string, leaf node, root node, nothing. It has only understanding of the what is
Right.
called numericals, numbers.
Values.
See, whenever anybody asks you the question based upon a machine learning or anything, especially a computers, simply think in terms of numbers. Then only you would be able to understand the behavior of the machine well. Fine. So, based upon the thing, we also have one more, the third parameter to evaluate whether the purity of the decision tree lies somewhere. That is called Guinea impurity. Guinea impurity. Have you heard this term somewhere? Yes or no?
No.
No, no worries. It's simply one of the mathematical computational tool to decide that whether what context should I carry upon. Say Guinea impurity is decided by it's very simple, 1 minus summation of I is equals to 1 to n probability whole square. That's it. How to expand it? We can call it as 1 minus, because now we have a probability of 2, either yes or no, that is a positive or a negative probability. So we will say p plus whole square, and see what should I add, minus or plus here inside, what number should I add, minus or plus?
Minus.
Why?
The plus.
What does the summation
Sir,
do?
sir,
If I say, sir, summation wi I equal to 1 to 5, what does the summation do? So won't the summation do I equal to 1 w1, then add w2, add w3, add w4 till w5? Yes or no?
yes.
Because summation does addition. I understood that very most of you are more likely to give me a negative answer. That's why I asked this question. So this summation will only give a plus sign. So please add here, no minus. So addition of the impurity, addition of the probability of the yes, and the addition of the square of the probability of the no. So simply we will do, say suppose we have two yes and two no's. Suppose in that case what happens, 1 minus probability of plus is half, because equal half equal no, square plus half square. How much does it makes? 1 half, 1 by 4 plus 1 by 4, it becomes 1 minus 1 by 2, it becomes 1 by 2. So it is 0.5. So can you correlate that whenever you had two yes, two no's, three yes, three no's, or a number of yeses and no's are equal, then we had what was the value of entropy in that case?
1.
No, 3 yes, 3 no's. Equal value. EHS, yes, very good. 1.
Yes,
Fine.
sir.
Thank you. Yes, yes, 1, 1. But now, Guinea impurities is having a value of 0.5. Now I will draw something to you. A clear picture shall be drawn in front of your eyes that how to decide. Say, we were having this probability curve, say starting probability curve, it would be p plus comma p minus. It contains p plus and p minus both. And this was the curve attained previously. Say if it is a p minus or if it is a p plus and vice versa, it happens both way around. So at this point here, when probability was 50%, you were having your HS value to be 1, but when the probability is 50%, what is the value of Guinea impurity?
P minus.
0.5. See, Guinea impurity, 0.5.
Point
Yes?
five. Yes.
So, may I draw the Guinea impurity curve that would be half of the entropy curve?
Yes.
So this is called Guinea impurity, which is having its maximum value as 0.5 for 50% distribution of the samples for yes and no's. So what do you think? Is HS faster or Guinea impurity faster?
HS value is
Faster,
more.
faster. See, HS has to traverse this path, but Guinea impurity has to traverse the lesser area. Which one is having the lesser area?
Guinea
GI.
impurity.
Guinea impurity. Thank you. If the Guinea
Yes.
impurity is having the lesser area, sir, the mind it, it will cover the whole computation faster than that of HS. Am I understood this?
Yes.
This is the situation we call Guinea impurity is faster. We call it GI is faster than
HS.
entropy. Entropy. Always call a full name such that you remember it. So Guinea impurity being faster than the entropy, it means you have to see actually based upon the highest value of the Guinea impurity and the HS, or what should say any value of Guinea impurity and HS, you have to decide. Okay, after this is a calculation, what to go for GI, that is called gain, IG, information gain, sorry, IG. See, they are very reciprocal. GI means gain impurity, IG means information gain. So never get confused between GI and IG. So IG, highest value, highest value of IG helps us, helps to decide what feature to start, what feature to start with. Fine. So these are the three things we have learned such that we can understand decision tree. So any DT is actually computed in terms of three parameters that is called entropy, Guinea impurity, and information gain.
IG.
I think now you are able to correlate the things. Now you find it interesting as a machine learning. Is there anyone who is getting bored, who is not getting understood, or any scenario? If anybody feels like, yes, you getting the concept, no, that why we are studying decision tree. I'm not making it superficial. I'm not making it going above the head, isn't it? I'm making each and every point clear, that how the machine interpret it, and how do you give as a fuzzy input and fuzzy out. Fuzzy means what you feel like, and machine feels nothing. Machine has no feelings. Machine only understand numbers, and the numerical output helps the machine to decide what to do. Like suppose I have already taken the parameter. If I give you the brief about it, let me just check it once. Okay, say here we have, fine, one second. Here we have like suppose when we will go for decision tree, so there are multiple parameters, we check it through. Parameters would be like that on what basis we are actually measuring the quality of the split. The quality of the split has to be measured, either entropy becomes zero or Guinea impurity becomes zero. So what do you think, Guinea impurity becomes zero faster or entropy becomes zero faster?
Guinea.
Gain
Guinea.
impurity.
Very good. So criterion, when we go for criterion type of, it's called a hyperparameter. I must write hyperparameter, not a parameter. Hyperparameters. Actually, if you remember, no, we used to write linear regression classifier, logistic regression classifier. So that we will also write decision tree, decision tree classifier. Okay. Inside this we have to decide number of parameter. So you write your one of the parameter as criterion. So criterion is given as, say, if you write Guinea, if you choose Guinea, you write it like Guinea, comma, then you give another criterion. Another criterion could be maximum depth. Do you understand now? Maximum depth, that how long your decision tree would look like. So say if you give maximum depth equal to none. Okay, if you give maximum depth equal to none means you hardly cares. You must know, you must go till the extent decision tree want to classify. Like we were asking the questions to Akinator, and it was uh, predicting the means coming to the final class or final label, that what uh, character we are asking it for. So it was asking us many questions, many questions. So depth was not decided unless until it found satisfied, then only the final prediction has been done by Akinator. Do you all agree?
Yes.
Yeah, so that is called maximum depth. Maximum depth, whenever we write none, that we leave the control that how long the tree would go. And such a situation actually gives to the problem of overfitting. Overfitting means it will keep on learning all the noises, all the non-required things, all the data which were trivial, which were not as important as it could have been. Like, is it really important that we ask the character that Akinator asked us, does your character live in your neighborhood? It might be required, it might not be required sometimes. So, but we have given maximum depth equal to none there logically inside the classifier. So they had created the Akinator as a gamification of decision tree. So that maximum depth is given none over there. That is the reason that it asked so many questions to it. So maximum depth would be one of the criteria, sorry, hyperparameter. Then we had a hyperparameter of how many maximum feature we would like to ask. Say we had uh, features of 70 features in a given data set. So it is not possible that we create a decision tree with 70 features. Can you imagine 70 features having their 70 different node and their different subnodes? So multiple features, multiple nodes, multiple subnodes. Where the tree would go? It would become a forest.
Yes.
Yes. Yes, yes, literally. So this is the thing that machines are actually intuited about. So there are, you won't believe, there are around 11 to 12 hyperparameters to be decided. Like we also give random state. Random statement, every time you choose the samples in a decision tree, the values, the sample of a data set, it must be shuffled, randomly shuffled. Do you remember this word random state from your train test split? Train test split, we use random state. Has anybody remembered it? Nobody. So if you remember, we had used train test split, and there we have give the training data set 70%, testing data set 20%, and random state equal to sometimes 4, sometimes 42, sometimes 3, sometimes 0. When we don't want our data to shuffle every time, we give random state equal to 0. Else, we give random state any non-zero value. Fine. So these are the things to be well understood. I think, does it make sense? Today's class has,
Yes, sir.
have you gone the gist of what may I call gist of mathematical interpretation, that how the decision tree is actually working, and what are the minimum what's called mathematical parameters which are making it understandable the machine is finding it through to take decision by itself. Because if machine doesn't understand that, how would it take a decision? So you have to understand first at your level in a high level language, and then you have to make the machine understand that please understand it, compare the results, and go for the result with either the higher value or the lower value. Fine. So this is all the things I have uh, thought of delivering in today's class. So I believe today's class must have went well. Is there any question to anybody? Please ask. Vinod KG is saying, hi, first time I am attending this webinar. Could you please allow me to record? Vinodji, this meeting is already getting recorded, and your what is called Eduwing administrator will share the recording with all of you. Don't worry. Okay. So let me close it. And so all of you, please, over your cameras. I'll let my head in such a situation such that it must be clear that yes, although my energy level is not down sampled, but yeah, my physical body is not allowing to. Thank you so much. Let me make this print screen. Okay. Thank you so much, all of you.
Thank you,
It
sir.
is literally pleasant meeting
Thank you
once a
so much.
week. If we can meet twice a week, it will be really good to all both of us. Just you make the things go well. Okay. But do visit every recording, everything within a week, at least 2 to 3 times. Then only it will be easy to digest it. Else, it would be a show passing by. Fine.
Okay, sir.
Yes, sir.
Okay. All the best. Bye bye. Take care.
Bye, sir.
Thank you, sir.
Sir, thank you so much.
Thank you.